The learning objectives of this section are how and when to use the various ARPA display modes, to understand the importance of using correct speed input to ARPA, to understand the effect of environmental forces acting on the ship. This is the navigator's dream ARPA, as designed by Siegel, where all primary functions are represented with dedicated function keys for easy and quick access, and giving an excellent system status overview at all times. Seldom used or secondary functions and parameter adjustments are available from a hidden keyboard, which can be extracted from the front of the ARPA console whenever needed. Click on the buttons for more information. The ARPA system startup procedure varies from system to system, however. The following points outline the minimum of what must be checked before an ARPA is operated in basic mode, that is, only for traffic surveillance. Overlooking one or more of these points may cause serious consequences. Switch on the ARPA and check that required radar is connected and properly adjusted. Check that the ship's correct course is fed into the system, that is, correct the gyro course if necessary. Check that the radar antenna alignment is correct. If not, correct it. Check that required log is selected. The log should provide speed through water, no correction for drift and current. Select required radar mode. Normally true motion course up or true motion north up should be used for traffic surveillance purposes. Select required range, vector length and collision warning criteria. Familiarise yourself with the ARPA manufacturer's recommended startup procedures and other recommendations. If navigation features are available in your ARPA and you intend to use them, the following additional points must be checked. Date and time should be displayed correctly on the ARPA information screen. Own ship's position input must be kept correct on the ARPA at all times. Otherwise, all positions calculated by the ARPA will be incorrect. In coastal areas, navigation checkpoints should be marked on the ARPA in order to assist the navigator in detecting a possible positioning error as soon as possible. Special requirements pointed out by the ARPA manufacturer. The main purpose of the ARPA is to provide the navigator with the best possible overview of the traffic situation at all times. In order to do so, today's ARPA can display any traffic situation in an easy-to-understand mode. More and more of today's navigators prefer the true motion, course up, true vector, see stability mode. This is the closest we can come to a bird's eye view with radar. The following pictures hopefully illustrate what an excellent presentation this is for traffic surveillance by ARPA. Here is a traffic situation as seen through the bridge windows in bird's eye view and on the true motion, course up, true vector, ARPA mode. The ARPA picture is stabilised at 240 degrees. Own ship's heading is 240 degrees. Speed 15 knots. Selector vector length is 12 minutes. Same traffic situation, but own ship has changed course 30 degrees to starboard. Observe that no rotation or disturbances of the ARPA picture takes place during the manoeuvre. Only own ship direction of movement is changed. Observe that the radar picture remains stable on the intended course during the avoiding action. The situation on the ARPA looks very much the same as the bird's eye view, with the bird flying on course 240 degrees. Own ship is now steady on the new course 270 degrees, and on the ARPA the course up reference is changed to the same direction, 270 degrees. Changing of ARPA reference can be done after, before, or any other time the navigator feels confident to do so. The big advantage of this is that the ARPA picture is not disturbed when the operator needs stable information most. True motion course up is without doubt the best presentation for traffic surveillance and for maintaining overview of the situation around own ship at all times. True motion course up, true vector is the closest we can get to what is referred to as positive instrumentation. That is, the instrument should provide the simplest and best possible overview of the information provided to the operator at all times. Whenever CPA, TCPA information is needed, this can be obtained graphically by pressing the spring-loaded relative vector button. Target's CPA, TCPA information is also available in alphanumerical format on the screen. Same traffic situation as before. The course change was executed in course up, but the ARPA is stabilised relative to north. In order to obtain the information as seen through the bridge window, the navigator must turn the picture 120 degrees in his head. Many navigators don't like the north stabilised picture, especially sailing on southerly courses, as they get the feeling of sailing in the wrong direction from this ARPA presentation. The relative motion north-up is a good presentation for navigation. However, it cannot be recommended for traffic surveillance, as it is not giving any information about calculating target aspect. The relative motion presentation is difficult to interpret correctly during dense traffic, requiring frequent course alterations. Talking about traffic surveillance by ARPA, this presentation should only be used when true motion is not available. Relative motion, head up, can be defined as the ARPA emergency mode. Only recommended when everything else is failing. Not recommended and not suitable for traffic surveillance at all. Relative motion, Head up is the presentation which gave the shipping industry the phrase radar-assisted collisions. Of course, the radar did not cause the many collisions. The collisions took place because the navigator did not understand the information provided, or the navigator did not have sufficient time to do proper plotting. All radar ARPA presentations presented so far can be classified as pure radar ARPA presentation. Over time, it's strongly recommended only to use pure presentations, as impure or mixed presentations can get you into real trouble if you should forget that a mixed presentation is actually what is presented on the ARPA screen in a critical situation. This does not mean that mixed presentations should never be used. Used correctly, during short intervals, mixed presentations can be very useful, especially on ARPA systems, which do not allow you to operate over time in mixed mode. That is, has secured that mistakes of this type can take place. Mixed presentations should be used with utmost care. Several collisions can be traced back to the use of mixed radar ARPA presentations over the past 15 to 20 years. When using the ARPA for traffic surveillance purposes, own ship speed through the water is highly recommended as input to the ARPA system. No correction should be made for current or drift. The main reason for this is that this is the only way to obtain target's calculated aspect. This is useful information when performing traffic surveillance by radar. Avoid using speed input from Doppler log or GPS, as this normally gives speed over ground. Fine for navigation, useless for traffic surveillance. Wrong speed input to an ARPA system working in true motion, true vector mode, could seriously affect target's calculated aspect. In the following figures, we try to illustrate the importance of correct speed input to the ARPA system at all times. All ARPA operators must at all times be aware of what speed input is used on their ARPA and the accuracy of this speed. This table presents the ARPA calculated result as given by 4 different speed input sources. Electromagnetic log, which gives correct speed through water. Manual speed input, miscalculated by plus 0.5 knots. Doppler log provides speed over ground without compensating for transverse drift. Doppler log provides speed over ground and compensates for transverse drift.